Okay, what I want to do is to look at the solutions of the first assignment. I have received many of your submissions. Most of them actually followed the rules, the naming convention. I think somebody didn't put the subject line the way it was supposed to be. So for this time it's fine, but from next time your email goes lost because everything is automated, and so if you don't specify the right subject, the email just doesn't get into the right folder. Okay. I also want to give the solution so that nobody thinks about submitting after the deadline, so that this is the end of it. What is the smallest floating point number larger than 2? I think that most of you guys understood this. It's just, it's a little tedious, but most of you understood the structure, how to get to the solution. So maybe I can do one of these 3 or 4 exercises, and then we move on to the last one. What is the smallest floating point number larger than 2? Okay, first of all, let's try how to represent 2. We know that 2 is a power of 2, so it's kind of easy to represent it. This by itself, without exponent, this is 1/2. So now we want to go up a couple of exponents to go from 1/2 up to 2. If we go times 1, okay, this is 1, and now we go to 2. Everybody agrees so far? Okay. What's the next floating point number? Well, now we go with all the zeros, and then we put a 1 at the very end. Okay. So, how do we figure out how much this is? Well, so this is 1/2 plus, this is 1/2 to the first, plus 0 plus 0 plus 1/2 to the, that's t, right? Which is what t is, 24. Okay, times 2 to the second. So the solution is 2 plus 1/2t minus 2. And 2 to the minus 22, which is, somebody can tell me? Can somebody do it? Come on, everybody has done it. Just give me the number.
60.
No, it's not 60. Oh, 6 zeros. Okay. Yes. And then it's a 538. What? 5. Really? Is that it? Yeah. I think it's a 238. Wasn't it 238? Yeah? Sorry?
I left it in binary.
Come on.
I don't know.
Okay, everybody agrees with that? Yeah.
So, question?
Yes.
Is it enough to submit only the 2 plus 2 to the power of minus 22?
Yeah, come on, it's fine. I mean, it would have been nice to write this, but fine. Sorry? Yes, it's true. This is not exact, but come on, it's just a matter of computing that. That's okay. Okay. Then, what is the largest point number smaller than 8? This is very, very similar. You just figure out what is 8 and you go backwards by 1 step. How many floating point numbers are in the interval blah? Actually, it's amazing. Many of you guys got confused by this. I don't know why, but Clearly, these are two successive powers of 2. Okay, so we will start from whatever this is, and we will go to the next one. We don't even care what k is, okay? We know that those are two successive powers of 2. So we have to go from here to here. So we have to fill all the possible combinations here. So we can flip all of these 0, 1s, zeros, and 1s, except for the first one. We cannot flip these. This cannot become a 0. It has to stay 1. That's a normalization. So how many possibilities? It's t bits, and we can flip all of them. So it will be 2 to the t, but we cannot flip the first one. So it's like that. And, okay, we cannot flip the first one, but we have to add the next one. So that's one. Okay? Yeah? Okay. Well, some of you maybe got confused by this. This means that we include both the left and the right interval. Anyway, it doesn't matter if you only wrote this, or it's not so important, okay? But the last one, it's very important. The last one, it's super cool, because it's really created confusion. Many people said that the largest integer is 0.1 times 2 to the e max plus 1. Yeah?
It doesn't, the exercise doesn't ask for the largest, but the first integer, so it would be the smallest, that cannot be represented exactly.
Okay, sorry, yes. So, are you saying that this is the right answer?
No.
Why not?
Because it's not the first.
It's not the first, exactly. So, yes, this is true, this is not representable, this is an overflow. But it's not the first number that it's not representable. And where is, there are several ways of figuring out why this is not the first representable. I think for me, intuitively, the easiest thing is when I told you that the floating point numbers are not equidistant, I showed you that at the beginning, two floating point numbers are, how far apart are they? Well, by 1 times the smallest integer. Okay, that's the distance between two of them. And then as you move from left to the right, the exponent starts increasing and the distance between floating point numbers grows. It will get to a point where this distance here is actually larger than an integer, larger than 1. Let's see when that happens. Okay, first of all, we're talking only about integers. So we want an exponent that makes this guy an integer. And for that, we want it to be at least 1. 2 to the 1 is 2 times 1/2. This is 1. Okay, so our exponent has to be 1 or higher. If we want to go to numbers like 2 or 3, okay, let's say 3, okay, I have this one, I want it to be a 2, so 1/2 times 4 becomes 2, and then I put 1/8 times 4, it becomes 1, 2 plus 1 is, did I say it right? The fourth one out, 2, yes, so, and this becomes 3. And so as I go up and I want larger and larger integers, I am shifting by adding larger and larger numbers here. Okay, exponents. And what do these exponents do? They change the size of the distance. There will be a point where blah 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 times 2 to the 24th. Okay, so this last guy here is 1/2 to the 24th. I multiply times 2 to the 24th, so we are at 1/2. Okay, that's not good enough yet. So if I go to the next one, 25th, now my distance is 1, okay, which means this is fine. I can still hit all the integers, but as I move up one notch, my distance between two numbers is actually 2. So I will start skipping integers. Yeah? So the first integer that is not representable is, let's see what it is. 0, 0, 0, 0, 0 so times 2 to the 25th. Can anyone compute this, please? This is 1/2 to the 25th. So it's 2 to the, so this is 2 to the -1, so it's 2 to the 24th plus, this is 1/2 to the plus 1.
16 million?
No. 16 millions? Is that right? Okay. Give it to me. 1.
16777 217.
No, 217. All right, let's see. So, single 16777 217. Oh, sorry guys. Yeah, you can see. Okay, so this is clearly not an integer. Let's see the 6. 6 clearly works. 5 works, and so on. Questions?
Why exactly at 24?
Why exactly 24? Because the mantissa is 24. How many of you didn't get it, or how many of you got it right? It's an easier question. Good. Maybe half of them. Okay, good. Now let's move on to the drama. I haven't seen all of the assignments yet, okay? Some of you are just submitted 2 minutes ago, so. But from what I have seen, this was pretty dramatic. Not because of the correctness. I haven't paid attention to correctness yet. I need some time. But because of a style. Come on, guys. I asked you to be inventive. I asked you to be artistic, and you got. Somebody actually came up with a beautiful slide with transitions, arrows, colorful. I like that a lot, but then the program was the old boring straight line program. Okay, let's look at how things could go wrong. So let's start with B sent, B received. Who said that this is MPI? Have I ever said this is MPI? Why did you guys submit MPI code? Come on.
Because it's nearly exactly the signature of the MPI function.
So what? You're supposed to abstract. Okay, next year I will remove the B, but I told you these are the instructions. They are available on processor. Somebody wrote MPI send. Come on. By the way, I make fun of you guys because I make tons of mistakes, so you can make fun of me as well, okay? We have a send and a receive and a synchronization. Let's solve this problem. As a guideline for the next assignments, if you find yourself thinking about a problem for hours, okay, that's fine. If you find yourself doing an assignment for hours, clearly you didn't get it. You're doing something wrong. I never ask for something that takes hours to do. It might take hours to think about a good solution, but don't spend hours for my assignments, okay? At least for actually programming them. Okay. So we had a matrix divided in 4 pieces. Processor 0 has A top left, processor 1 has A top right, and so on. Processor 2 and processor 3. A bottom left, A bottom right. Okay. And the first thing we want to do is processor 0 wants to compute A top left plus A top right. Correct me if I'm wrong. Processor 1 wants to compute A top left minus A top right. Is this correct? I don't remember. Processor 2 wants to compute bottom left plus A bottom right. And processor 3 from left minus A bottom right. Okay, so processor 0 cannot start the computation. Why not? It doesn't have A top right. Processor 1 is missing A top left. Same story for P2 and P3. Let me write the program for P0 and P1 maybe. P0, and by the way, this was very important. When I showed this example, I also showed the example of the inner product between two vectors, and I showed you how it's possible to send a whole piece of a matrix, for instance. So most of you, or maybe actually everybody, used just one send or just one receive to transfer A top left or to transfer A top right. This was very good, and it's probably because I showed you. But the moment when you guys had to do this, now the troubles start. How many of you actually used, okay, no, I don't want to know, but some of you actually used the for loops, for I, for j, and then A top left, ij plus A top right, ij, and blah, blah, blah. Does this look familiar to some of you? Do you see a total disconnect between the math and the program? And I asked you to use your favorite imaginary program. I never asked you to use a C or to use whatever. Why do you think in terms of entries when the math talks in terms of matrices? This is actually a demonstration that the programs, the languages that you guys have worked with so far, destroyed your intelligence. So you're not thinking in mathematical terms anymore. You're already thinking, oh, C, or I don't know which other language you were thinking of, C wants me to work at the index level, and you totally forget about what you're trying to do. This is so bad, guys. We want the languages to let us do math or whatever other topic, whatever assignment we want, and we should be able to think in terms of what the math tells us, not in terms of what the language lets me do. Especially when I ask you, invent your own language, okay? So please, don't do this. This is not how we describe the operation. Somebody last year, I made the observation, was a very good student. Actually, it was a 1.0 student. So, and he started arguing with me, and he says, well, a matrix mathematically is defined in terms of its entries, ij. And so for him, it was perfectly reasonable to do this thing. Then I can argue, any number in a computer is defined in terms of the bytes or even the bits. So why don't you go ahead and add every single byte or even the bits of the numbers? What I'm trying to say is, this is a really important lesson. Don't let the language affect your thinking. Think in terms of mathematical terms. Think at the mathematical level, and the language then should follow. Then, if you go for high performance, there are only two possibilities, C or Fortran. Okay, at that point, you have to twist your thinking because you want to cast your algorithm in terms of C or Fortran constructs. But this is exactly the purpose of this class, to use Matlab and Mathematica to work at the same level at which we think. Okay? So, now, let's go here. Let's say that P0 sends A top left to P1. Let's put a tag. Okay? P1 knows that P0 needs A top right, so it starts sending A top right 1, and okay, let's use a 0. Let's use a different tag. Oh, I see some hands. Yes. This leads to a deadlock. The sends and the receives of assignment of part number 1 only go through when a corresponding receive or send is issued. So this send will never get through because this send waits for a corresponding receive. Receive whatever from 0, tag 0. Too bad that the processor will never execute this receive because it's stuck onto this send. Why is it stuck on this send? Because this guy is hoping that the processor 1 issues a receive. But processor 1 cannot issue a receive because it's trying to send. So here we go. We start with the deadlock. The two processors that are communicating cannot both start with a send. If you flip these things, life is much better. So let me track. Okay, and then send. Similarly over here. We need these two things to be different. It's okay to start with the receive as long as this guy starts with the send. Yes?
Yeah, I was just asking, will both receives make it also a deadlock?
Yeah, same story. Because both the sends and both the receives are blocking. Okay, so let's say that we have done this correctly. Do I have? Yeah. So let's say that we have done correctly. So at this point, processor 0 finally has A top left and has A top right. And So let me write it. Receive. I don't remember. What is the syntax of receive? What's the first? What do I put here? Okay, so let's say that it's buffer, and I receive. I don't know, from 0. The tag is 0. Okay, and then I send. Okay. Moral of the story: this guy also has a top left and a top right. Maybe I should make it more clear. This is the actually a top left, and this is buffer. While this guy has buffer here, and here a top right. Okay. Now we have to add or subtract these quantities, and we have a dilemma. Where do I store the result? Do I put it into a top left, or I put it into the buffer? So do I overwrite my local data, or I overwrite what I just received? Local? What did you say? Local? Oh, I like this answer. Who said it doesn't matter? Yes. I like it doesn't matter. Why would make a difference, or why it wouldn't make a difference?
Because the computer it doesn't care which one is the buffer or not. It just knows there's information here, and you need to tell it where to get the information from for the next step.
So, very good. You're talking now about the next step. In the next step, we will have these guys talking to one another. We want P0 to talk to P2, and P1 to talk to P3, and vice versa. So we want to be prepared for the next step. So the comment is, who cares, as long as I tell, in the next iteration, I tell which of the buffers to send or where to receive. It doesn't really matter. Other opinions? Yes?
We don't need the original values anymore of each of them, so it doesn't make
So all of these answers are correct. We don't care. Why? Because when I send and when I receive, these instructions are blocking. So I don't have to worry about if I overwrite on a top left, maybe my P1 will not receive the right data. I don't have to worry about that, because my receive completes only when there is a corresponding send, vice versa. My send completes only when there is a corresponding receive. So if I get out of the send, I know that P1 has received the data, which means I don't need a top left anymore. I can override it. Okay? So it doesn't matter if your result overwrites a top left or overwrites buffer. No difference. Okay. Then we have another dilemma. Now, B top left, B bottom left. Okay, now what the math tells me to do. Math tells me to do C top left equal B top left plus B bottom left. Again, please correct me if I'm wrong. P1, or maybe it's better to start here. P2 says C bottom left, B top left minus B bottom left, C top right, B top right plus B bottom right, C bottom right. This is P4. This is P3, yes. B top right minus B bottom right. Okay. A lot of writing, but what matters is that now the communication will happen vertically. Before the communication was horizontally, now it's vertically. Okay, so P0 now wants to send, well, you see, P0 now owns B top left. This is local. And in order to execute this assignment, he needs B bottom left. B bottom left is in P2. Okay, vice versa, P2 needs B top left from P0. So there will be a communication between them. And the question is, do I sync or not? Sync or not? I would like somebody to support the sync.
After what? After 8?
After the addition.
After the, I will support it.
You will support it.
Kill them!
Give me, give me some motivation. Why do you?
Because all the processes, they perform this operation, so the first process can achieve the section with second addition, while the previous one didn't get the value from the previous operation.
That is everything you said is true, but that doesn't imply that you need a sync. Because let's say that now the processor starts sending whatever he has is local. He sends it now to processor 2, okay? And maybe processor 2 is still working on this addition, so it's not ready to receive. That's no problem. This only goes through when processor 2 issues a receive. There is no fear of overwriting. The processor will stay here in the send until processor 2 says, I'm ready, send it to me, and vice versa. So no need for synchronizations. Yes?
Yeah, but it practically doesn't matter because the computation is finished when everybody is finished. And assuming that
That is very true.
that the sync is doesn't take any performance hit, we are already waiting for the slowest processor.
So you make good points, but wait. First of all, we're not discussing the final stage. We are discussing the intermediate stage, okay? So processor 0 and processor 2 could start communicating with one another before processor 1 and processor 3 are done. There is no need for them to wait for processor 1 and 3 to be complete, okay? What you're saying is absolutely true, and it's a consideration to do for the next step. Yeah?
Also, what we can say, sync takes performance or not, it doesn't matter because the exercise says minimize the number of syncs.
I promise he's not one of my PhD students. Okay, so that's a good observation. We don't need a sync, so we can now send and receive. And same story, we can add into our local or into the other, into the buffer. Yeah?
You should change the tag of your send since 0 is already in use.
No, I'm sending to a different processor.
No, the tag, not the receiver.
Yeah, I'm sending to a different processor.
So it doesn't matter.
Doesn't matter.
Use tags twice.
For sure. I'm sending to a different guy.
It must be fine to be unique, the exercise.
Yes,
Since we
Okay, fine, guys. Sure. All right. Okay. That is an integer.
Why don't you use Japanese characters?
Let's move on. The question is, at the end of after this second step, do we need a sync or not? So For the correctness of the result, clearly we don't, but in order to be able to say my computation is done, there is no other way to do it but to put a sink in the end. Otherwise, I will never be sure that all the 4 processors have completed the computation. Remember, there is the communication. Yes, you can say for sure that the communication goes through when a send and a receive are matched. Computation, no. So
We had the same computation in the previous step.
yes, but in the previous step, this is a philosophy. In the previous step, you don't need synchronization, because what is the purpose of the synchronization? Would be to protect your data. Okay, down here there is no protection anymore. Down here, the data I want to sync just to say, after this sync is done, I know for sure that C as a full matrix has been computed.
So basically, you mean to say it just separates the above MPI part with the communication and computation part with what follows after sync.
Well, the exercise was to compute the matrix C. How do I know that I have computed the matrix C?
How do you know that you have computed matrix B there?
I don't, but I don't care.
But you could just wait for all of the processes to return or finish the computation.
And how do you know?
But
Because
computation
there's some way of
Okay,
return.
if they terminate, that's fine, sure. I don't take this as a mistake, but think about it. If you want to know when C has been computed, you have to put a synchronization. Yeah.
I think sync at the end is more of a confirmation more than a safety.
It's not a confirmation, otherwise you don't know. If you wanted to do something else on the matrix C, when could you start? You don't know. Until you put a sync and everybody passes this sync, you cannot assert that C has been computed.
But how do you know that you passed this thing?
You wait.
Yeah, but how do you know? How do you see from the outside?
You put a print after sync.
But you can do that for each process.
Okay, you can, if the processors terminate, if the threads or processes terminate, it's fine. This is philosophy. We didn't have this kind of guidelines. Okay, other questions about this? Then let's move on to instruction set number 2, which was much more juicy. Some of you clearly had fun creating the language. It was nice to see that you enjoyed that. Unfortunately, you were not so inventive from the artistic perspective. Should I show what the instruction set number 2 is? No, everybody is familiar? Okay. So now P0 needs to fetch some data from P1. Get something, I don't remember. Actually, I have to say buffer. Get a top right from processor 1, tag 0. Okay, I know what you're going to say. Calm down. So, philosophical question. Should I have a sync before this? Nobody is in favor of a sync ahead of... I know you are. You asked me. Come on.
If you can't be sure that all the processes are running, you need a sync.
Well,
Or if we can't access the memory without the process.
Yeah, I would say that before the computation starts, I think that everybody to have a sign that all the processes are ready for computation.
very good. Yes. So I didn't make it clear because I guess I said that the processor starts having a top left or having a top right. So, but if in real life, if you will ever program something like this, you have to sync. You need to make sure that all the processors are actually ready for what? Ready to be read. Because now I'm going to go into processor 1, I'm going to fetch some data without processor 1 knowing. I'm sneaky. So I better put a sink to make sure that the data in processor 1 is ready to be read. Okay? So having a sink ahead of time is not a mistake, and I actually like it. Now, we have a buffer, we have a get, processor 0. Okay. Does this create problems? Silence, no problems. Very good. Now we have a top left and buffer. And we want to do this. And we want to put it, so a top left or maybe buffer. Same dilemma as before. Oh, now there are opinions. Yes, I don't hear you very often. What's your opinion?
I would like to data into buffer because there could still be some another processor be reading from my additional data.
Yes, very good observation. Observation is, if I overwrite my a top left, how do I know that the get from here, this a top left, is being read? How do I know that this get has completed?
We also, before we start the whole reading from our buffer, we have to wait for our get to complete.
Oh, yeah, sorry. There is a...
It's kind of premature to worry about that.
Totally forgot about that, sorry. So first I have to make sure that this get completes, sure. Okay, so not a good idea to overwrite my a top left. So we actually overwrite buffer. This is the right assignment. And here the mistakes start because I'm sure that several of you overwrote a. Somebody did?
Yeah,
Yes.
one could do this if one uses a sync after complete. But
Yeah, but the exercise was minimize the things. Okay, so we have to do that. At that point, my guy here wants to get B bottom left from the processor down here, which is the 2, same thing as before. And okay, buffer is containing my B top left, right? So buffer is equivalent to B top left. So I better not store my what I'm getting onto the buffer, because that's my local data. So I can store it into a top left instead. Who has problems with this? Somebody has problem? Yes?
yeah, but now, for example, what if it's doing that part, but this processor 1 hasn't finished?
Very good.
So you need a sync after this complete.
Very good. What's your comment? Was it the same? Very good. That's the same story. These a top left, this data, just because I got something, just because I did some math, and a lot of time has gone by, this is not enough to say that processor 1 has completed its reading of a top left. I cannot assert that, so I cannot overwrite a top left. Yeah.
And furthermore, what about B bottom left? It may not have computed yet. Right?
This is another good point. Yes. So I was focusing on a top left only. What about this guy here? How do I know that it's ready? That is another very important point. So I'll make sure that everything goes smoothly. The answer is simple. We stick the sink at that point. This solves all of our problems. So what do I know now? At this point, I know for sure that this guy finally read my damn 8 up left. I can get rid of this 8 up left. So, 1 second. I also know that it's after the computation, so I know that B bottom left is available. What was? So the comment was.
Someone need to specify what B bottom left is, because at the moment we didn't specify B. We only have A and buffer.
What do you mean? So another mistake is to stick the sink before the math, before the computation. What happens then? If I put the sink before the computation, one of the problems is solved, but not the other.
Another processor could be computing what it's reading, and I take the results from this processor before it finishes.
Yes. So, yes, what you're saying is that I am getting bottom left is data, but I don't know that the computation in this processor has completed. So, yes.
But my problem is, I think you need 2 sinks here because
Ooh, 2 sinks.
After the complete, you know that it has all the data it needs. But I think you need a sink right after the complete, and then right after the computation, because as it's reading top right, or it's getting the information it needs. Then if there's no sync, then maybe this guy here is already doing the math and overwriting.
After the complete, you don't care about you don't care what he does. After the complete.
I mean, what if this guy is complete?
Yeah.
But
That's another one.
you're storing the buffer anyways, you don't need to.
Yeah, you're storing, this is crucial. You're storing into buffer. If you overwrite your 8 up left, then yes. But you can avoid that by storing into buffer. Okay? The other guy reads your 8 up left, and that's why you leave that untouched. You store it here. And you make sure that the data that you want to get is available by shifting the sync after the computation. Okay, so now we have a get, and we can do our math. We can do whatever we need to do for C top left, and then, do we need a sync in the end? Yes.
Same question as before, but we still need a complete.
Clearly, I am skipping the completes. Okay. Do we need a sync down here?
Actually, I have another question. What
Yeah.
is this complete? Just tell me that the communication is done.
Yes.
Okay.
The get statement is done. We
That
got
the
that
get,
before, but
that the
So
get.
that all
it
the
doesn't care about
information is
gets
there.
of the other process.
Yes.
Okay.
So this is the same story as before, right? The sync is necessary to be sure that the matrix C as a whole has been computed. If you didn't put a sync, I think, has anybody put a sync at the end? Yeah, okay, good guys. Okay, now I cannot claim who the winner is because I have not looked at all of your assignments, but let me just give a suggestion. Why didn't we say, okay, here is my language, I plot time like this, so as I go down, there is an increase of time. It's a sequentiality. And then I say, send, actually, this is P0. Then I put an arrow, which means, okay, I'm communicating. And then I say send A top left to processor 1 and 0. And over here there is a receive from, okay, there is buffer. And then there is from processor 0 tag 0. And then there is a send. Actually, it's here. Now there is a send here. And so on. Then down here I have some math. A top left plus A top left plus A top right. And then I have,
We have the receive.
yeah, I have a receive here, that's right. So receive, I put it here. Sorry, I wanted to put the receive here on the arrow. Here I have a receive. Then it gets difficult. How do I do it vertically? So maybe it wasn't as easy as I thought. But I just came up with this. It doesn't work exactly.
We can actually turn it around.
Yes.
Yes,
What's your comment?
Well, first off, you could just say time goes from the inside to the outside, make the whole thing into a spiral, and
You could also draw it in 3D.
However, to do that, you have to do a lot of writing, and just doing the whole thing as like a 10-line parametric program is a lot easier and faster.
Faster, wait. Faster is only in terms of...
Faster to write.
Okay, anyway, I don't want to give it away. Let's, next week I'll tell you who the winner is.
So there's no more intelligent solution than this.
Intelligent. Come on.
Intelligent.
Elegant. Okay, for me the elegant solution is not a parametric program for this. For me the intelligent solution is to have the page, the program that has 4 quadrants. And this quadrant, there is the program for processor 0, here is the program for processor 1. The communication is actually matched with an arrow. So there is a send, and over here there is an arrow, and there is a corresponding receive, and vice versa. It's visual, so it's something that speaks for itself.
So only more elegant in the visual way, not in the
Yes,
content of the program.
absolutely. As I said, I want it to be readable, self-explanatory. But I don't want to say. I want to look at all the programs, and maybe parametric one would win. I don't know. Yes, somebody did. Yes. Okay, enough. Matlab. So last week, 2 of the examples I tried failed miserably. I don't know why. So I tried them back at home, and they worked. So now we're going to try them again. Let's say that C is a random 4x3 matrix. And then I want to see D is a logic matrix. It tells me which entries are greater than 1. If I do who is of D, no, I don't see anything, but I see that it's a matrix of logical numbers, 4x3, okay. And if I say E equals D times 3, okay, works perfectly. I don't know why last week.
I think because we changed the domain to.
I actually applied the plus, and the plus doesn't do it. But if you multiply, divide, or do other things, it works.
Wasn't it just one entry you wanted to modify and this didn't work?
Yeah, actually, okay, let me show the whole story. Anyway, who's of E, now we have double numbers. So we multiplied booleans, and now they are doubles. What I wanted to do is take D and change one entry. Yes?
If you change to D is equal D times 3.
Oh, now you're going to kill my logic. So,
What should be under attributes, if any?
say it again.
What should be under attributes, if any?
I have no idea. Sorry. Okay. So it with additions and subtractions, it lets me change. I don't know why we're looking at this. This is a waste of time, but so I can do this. D22 equals D22 plus 1, and that actually works. See, the 2 entry was a 0, now it's become a 1, and this is still a Boolean. So you can do this kind of.
So do this again. So
No, it's not going to work again. It's going to stay. So it works, it operates as if these were actually Boolean numbers, except that it lets you do things as if they were double numbers as well, so it's a bit confusing. Okay, then we add this matrix, and I tried to extract a 0 by 3. In this case, last time it was a 6, and I was trying to extract a 0 by 6 vector. I don't know why it didn't work, but so just to give you an idea, 0 by 3 is perfectly fine. It's an empty matrix, 0 by 3. And if I do C of so I am extracting the God knows which row of matrix C. It correctly extracts a 0 by 3 row. I don't know why it didn't work last week. This is what I was trying to do, but I think for the purpose of this course, empty matrices are probably going to play little or no role whatsoever. But if some of you will take my class next semester on the generation of algorithms, empty matrices play a really big role. Okay, I want to show you some other horror stories of Matlab. Yes?
So 1, 0 is 0 by 0, right?
No. 1 column 0, it's an index. So 1 column 4 creates all the enumeration. So 1 column 0 is the empty.
That's a 1 by 0.
Okay? Okay, I want to show you some other horror stories, things that you have to be careful or maybe not. This is just to show you that Matlab is not a functional language, again, in contrast to what we will see with Mathematica. I told you that this creates a list, right? Yeah? Sorry, vector, yes. And square brackets create a vector. And I told you that parentheses access a vector. So what is this? This is so frustrating for me. You cannot do that. Yeah.
Actually, Octavia does it.
Well, good for them. Octave. Okay. Why this doesn't work? Because I don't know why they decided not to make it work, but if you store it into a vector, and then of course vector of 3 is what we want, but you have to store the computation first and then perform a functional call or an access. Okay, I have another example. I didn't show you I. I is a super important command. It creates the identity matrix of size as the argument, size 4. Okay, so it's a matrix. Now, if I say I of 2 by 2, how many would like to see a 1 out of this? I am certainly one of them. And unfortunately, we cannot do that. You might say, it's parentheses. Okay, let's add a few extra parentheses. No, it really doesn't let you do it. You have to store the result first and then Okay? And this is the clear proof that this is a procedural language. So you do one thing, another, and not a functional language where you just nest all of your function calls. Okay. The syntax of Matlab is such they overload the operators and the functions like crazy. I don't know if you have ever seen overloading like this. Let me show you. You say IG. Oh, first of all, I need to create a random matrix. We have a random matrix already. Is it C? Yes. Yeah, but it's not squared. Okay. IG of C. For those of you who know what eigenvalues and eigenvectors are, IG is going to compute eigenvalues and eigenvectors of the matrix C. For those of you who don't know what eigenvalues and eigenvectors are, it doesn't matter. I just show you. Matlab will solve this problem. Cx equals lambda x. Okay? That's what it's going to do. And it spits out the eigenvalues. So it's telling me the lambdas. Okay. So far, so good. If I want to assign this output to a variable, I can simply say eigenvalues equal, and now my E contains that. Okay? Now look, if I do this, I am changing the assignment, the output, okay? Function call exactly the same, output different. Now both A and B are assigned. What I add, my eigenvalues, if you see, you can see the 663, the 314. The eigenvalues now are the diagonal of B of this matrix. So first it was returning a vector, now it returns two matrices. What I add store into a vector, now it's stored onto a diagonal. And now I have some other numbers that I didn't even have before. It's all the matrix A and are all the eigenvectors X. So in a way, you feel like Matlab is computing more than what I am assigning. If I only put E as an output, like, okay, but maybe Matlab computes more. So you kind of have the temptation to say, what if I do this? Maybe it has 3 outputs now. It gives me... Well, no, for I, it stops at 2 outputs. Okay, but this is not the end of it. So let me create... Oh, we have A. Okay, so... Now I call I with 2 matrices. Okay? It doesn't matter that A is the result of a previous computation. Just say that these are 2 matrices. And it's still computing something. Well, now for those of you who know a lot of linear algebra, now it's solving a completely different problem. Now it's trying to solve, not it's trying, it's actually solving this problem, which is a generalized eigenproblem. There is an extra matrix. So it's doing something completely different, mathematically different. And as you can guess, here we go. And now I have eigenvalues and eigenvectors of a generalized problem. I can give you more examples like this. What I'm trying to say is pay attention to the arguments, different arguments. Let you, or actually affect the function in a pretty dramatic way. They change what the functions compute, even the outputs. So if you specify 1 or 2 outputs, you get different quantities. Yes?
But usually in Matlab, if there's multiple outputs, it would give all the possible outputs.
No. Look, I of C, it only gives you the eigenvalues.
But this is a specific function which gets the eigenvalues of matrix C.
Sure.
But with the one with the brackets A, comma B, that's a different function.
How is this a different function? It's the same call.
Yeah, it's the same call, but it's overloading to a different.
As I said, they are overloading like crazy. So I'm simply saying there is nothing wrong. I'm simply saying pay attention. You want to do something, you assign the computation to a wrong variable and you don't get what you want, okay? So I'm simply saying pay attention to this. Let's move on to another horror story. So random of 4. Well, we have that already. We have diag. What do you think diag does? The diag? It takes a diagonal of a matrix C, okay, and stores it as a vector. Okay, this is intuitive.
Why is it a kind of vector?
It's a what?
Why is it a kind of vector?
I don't call myself Cliff Moller. Okay, now we call diag of a vector, and look at that. Now we get a matrix. We started from a matrix, diag gives us a vector. We start from a vector, diag gives us a matrix. This is horrible, okay? But it's actually useful in a way if you want to. You can do things like this. What is this? That's true. This is just a diagonal matrix with the diagonal entries of the matrix C. We have gone from a matrix to a vector to a matrix. Yes?
You could receive the same result by diag C point multiplicating with I once 4.
That's a very good point. I like this. I is of 4. It's I.
Once.
Oh.
Okay, it's the same.
No. Why doesn't it work? Oh, not diag. Sorry, not diag. Yeah.
Okay.
Sure, that's a good suggestion. You didn't suggest that quite, but that's okay. Yes?
Do we get as output when we put something like a three-dimensional array into block?
So I'm gonna go easy. I will create. Okay, tells you clearly it wants 2D. Okay, with the diag it's not over, and I want to show you this because it's actually very useful in practice. Let's say that we have 1, 2, 3, 4, and now we pass a second argument, -1. What do you think this does? So,
The inverse of the
Minus 1 where the zeros are.
sorry?
Minus 1 where the zeros previously.
Oh, no, not quite.
Minus 1 of the diagonal entries?
Nope. But these are good suggestions. Okay, what it does, it puts 1, 2, 3 in the sub-diagonal. Sub because it's -1. Had I put a 1, it would be on the super diagonal. And now I'm just curious, I don't know. No, now C is a mess. I don't know what this does. I hope this takes the subdiagonal of the C. Yes, it works perfectly. Okay, enough of this. I just wanted you guys to be aware of these things. So there is a function overloading like crazy, okay? Pay attention. How to solve these problems? Well, help IG. And fortunately it tells you. So with one output it does that, with two outputs it does something else, with two inputs and one output, two inputs and two outputs, and so on. Help LU. LU it's even better because it has, you can see how many outputs. It's pretty cool stuff. Just pay attention to these things. Okay. We don't have much time. Okay, I'll see you next Thursday, right? Bye-bye.